All right, my darlings, here is lesson 1. We talked about the vocabulary in lesson 0. Now that you have familiarized yourselves with the vocabulary, we can now focus on adding, subtracting, and multiplying polynomials. You've seen it before with combining like terms. We're going to take a look at it again at a slightly more advanced level because, I mean, come on, you guys are honors. So first and foremost, we must remember how to classify polynomials. We use the degree and the number of terms to do so. So remember the number of terms. If there's only one term, we call it a monomial. If it is a binomial, it's got 2 terms. And if it has 3 terms, we call that a trinomial. 4 or more is a polynomial of 4 plus terms. Degree. If there is a 0 degree, that means, suppose we have a variable x raised to the 0 power. Anything to the 0 power is a 1. Look at that. It's a constant. 1 is a constant. If the degree is 1, x to the first power, then we know that's linear. X to the first power is simply x. It's a quadratic when it's x squared. X cubed makes it a cubic. X to the 4th is quartic, and x to the 5th is quintic. 6 or more is a polynomial of the nth degree. We'll just call it nth. Okay, n symbolizing more than 5, 6 or more. Okay, so if it's 6, you would write 6. If it's a 7th degree, you would write 7, so on and so forth. All right, so we're going to go ahead and describe polynomials, taking a look at number 1. The number of terms. Remember, each term is separated by a subtraction or addition sign. There are 4 terms here. Here's 1, 2, 3, and 4. 4 terms. The standard form to this, remember, standard form is when your exponents are written from greatest to least in descending order. We're going to focus on the exponents. So we've got this negative 3x to the 4th. Notice how I'm taking the sign with it, the sign in front of it, negative 3x to the 4th. Then we've got a negative 4x squared, so minus 4x squared. And then we've got x to the first power here, and that's a positive 6x. And then we've got our constant. There's no variable on it, so it's a constant, plus 1. This is written in standard form. Our leading coefficient can only be determined when it is in standard form. That's going to be the number, the coefficient in front of your degree. Okay? So your leading coefficient is a negative 3. The degree of this polynomial is 4. When you go to classify this, because there are 4 terms, it's going to be called a quartic. Okay, let's go ahead and do number 2. I'm going to fly right through this. There are 2 terms. It's separated by a subtraction sign. So we've got 2 terms. Standard form to this guy is as follows. Oh, it's the same. 2x squared, y cubed, minus 5x cubed times y. Now hold up, Miss K. Isn't x cubed bigger than x squared? Of course it is. However, as we discussed in our definitions in vocabulary 0, we have a leading coefficient of 2, but our degrees here is to the 5th. You add your exponents, you add your powers together for that term. And remember, this term is separated by a subtraction sign. For your second term, you add your exponents. That's x to the 3rd times y to the 1st. So that's a degree of 4. So clearly, 5 is bigger than 4. Your degree of the polynomial is going to be 5. And this particular polynomial, when classified, we call it a binomial. Number 3. It's a trinomial. There are 3 terms separated by a subtraction and addition sign. Standard form would be a negative 6y squared plus 7y plus 5. Your leading coefficient here is a negative 6. Your degree is 2. And when we go to classify this, we call it a trinomial because it has 3 terms. Let's take a look at number 4. Again, we have 3 terms. This is a trinomial. Take a look at the variables and the exponents. This has a degree of 2. This has a degree of 2. And even this fellow has a degree of 2. So each term has a degree of 2. How do we know which standard form it goes in? Well, that's where we take a look at our variables. A, AB, and then B squared, right? So we're going to go ahead and start with positive 4a squared. A squared comes before A because, the A here, because you have a degree of 2 on the A. Exponent of 2 on A is bigger than an exponent of 1 on A here. So your next term becomes 6AB. And then your last term is going to be minus B squared. Remember, it has to go in alphabetical order because this guy has an A. Your plus 6A comes next. Your plus 6AB comes next. Okay, your leading coefficient is a positive 4. Your degree of the polynomial is 2. All right. Like terms, you already know what like terms are, 2 or more terms of a polynomial with the same variable raised to the same exponent. Those are your like terms. So when we first learned this, I had taught you to, step 1, rewrite your entire expression without parentheses. So we're looking at 4x squared plus 6x plus 7. I'm just bringing it down without the parentheses. Bring down your addition sign and bring down the rest without parentheses. 2x squared minus 9x plus 1. At this point, we're going to go ahead and combine like terms. We have the highest degree, which is 2, so that's a positive 4x squared plus 2x squared, which gives us 6x squared. Descending order would be positive 6x minus 9x, that's a minus 3x. And then we've got a plus 7 plus 1, positive 7 plus 1 gives us a positive 8. And voila, there you have it. Trinomial, standard form, simplified. Here we go. We're going to collect like terms and write it in standard form. This case is a subtraction, so we're going to rewrite our entire expression without parentheses, but this time we're going to make sure we distribute this subtraction to each term in the parentheses into the polynomial after it. So here we go. Bring down your 7x cubed minus 5x plus 3. Distribute, you get a negative 7x, positive 4x squared, minus 9. Combine like terms. Let's collect like terms. We don't have any other x cubes apart from this guy. So we've got a 7x cubed. Next comes an x squared. Our other x squared is right here. There are no others, so plus 4x squared. Notice how I'm taking the sign in front of my term. And now the family of x's. We've got a negative 5x minus 7x gives us a negative 12x. And last but not least, we've got our constants. Positive 3 minus 9 gives me a minus 6. Quartic, 4 terms. Our polynomial is written in standard form. Go ahead and turn the page. Take a look at number 7. Remember, in the event you feel like I'm going too fast, hit the pause button. Hit the rewind button. Do what works for you, but pay close attention. In number 7, we have 2 times a trinomial. Distribute that 2 before you rewrite the entire thing without parentheses. So you're looking at 4p cubed plus 20p minus 12p squared. Bring down your addition sign and bring down the other part of your expression. Notice when you apply the distributive property here, nothing changes because it's an addition sign. All right, at this point, folks, let's collect all the like terms. We've got a positive 4p cubed and a positive 4p cubed. No other p cubed families, so we'll write that as an 8p cubed. Let's check out our p squares. Our p squares are here. There are no others. That's a negative 12p squared plus 11p squared. That gives us a minus p squared. A negative 1p squared, but we don't write the 1. And last but not least, we've got positive 20p minus 3p gives you a positive 17p. Trinomial, standard form, your exponents are in descending order, 3, 2, and 1. Number 8. Again, same idea. Bring down your first expression without parentheses, v cubed plus 6v squared minus v. Distribute that negative 3 to each term into the trinomial after it. So this now becomes a negative 27v cubed. Negative 3 times a negative 7v cubed gives you the positive 21v squared. And then negative 3 times positive 3 gives you a negative 9. Now you can go ahead and combine like terms. We have a positive v cubed minus 27v cubed. That's a negative 26v cubed. There are no other v cubes. So now we're going to focus on the v squares. Remember, we're going in descending order. We have a positive 6v squared, a positive 21v squared. That's a positive 27v squared. And then we just got this minus v, chilling like a villain with Bob Dylan. There's no other v's. And bring down your constant. Minus 9 is your constant. Constants always go at the tail end. And this is a quartic. 4 terms, standard form. Our leading coefficient, just for the fun of it, leading coefficient is a negative 26. Our degree is 3 because our exponent, the highest exponent, is 3. All right, moving on to number 9. Again, we have this negative sign. Don't forget to distribute it. So here we go. Bring down your first expression. With the distribution, you have a minus x cubed plus 8x squared minus 11x. Now go back and combine like terms. Here we go. Positive 2x cubed minus 1x cubed. That is x cubed. Let's check out our x squares. We've got a positive 5x squared plus 8x squared. No other x squares. That's a positive 13x squared. Let's check out our x's. We've got a minus 3x minus 11x. Notice how I'm going in descending order. This is a negative 14x. And then look for your constant. There it is, minus 8, and that is all. Again, quartic. 4 terms. Leading coefficient is 1. Your degree is 3. Take a look at number 10. Again, apply the distributive property. These are negative turning to a positive, and a negative times a positive is a negative, all right? Bring down your 4xy minus x squared. When you distribute, you get a negative x squared times y plus 7x squared minus 9xy. Okay, combine like terms and put it in standard form at the same time. We have negative x squared plus 7x squared is a 6x squared. We have y's involved too, but we want to handle x squares first, alphabetical order. So now I'm going to address the minus x squared times y. And then we've got the positive 4xy minus 9xy. That gives us a negative 5xy. This becomes our trinomial. Our leading coefficient is 6, and our degree is 2. All right, folks, let's talk about multiplying. This was all addition and subtraction. Let's go ahead and address multiplication. I'm going to teach you 2 ways: straightforward multiplication and the area box method. So if we were to multiply 23 times 34, as we used to back in elementary school. 4 times 3 is 12, carry the 1. 4 times 2 is 8, plus 1 is 9. Bring down a 0 over a placeholder, and 3 times 3 is 9, and then 3 times 2 is 6. If we add these numbers up, we get 782. Okay, you could use a calculator, sure, but I'm trying to make a point here, so indulge me, my darlings. 23 times 34 is the same thing as saying 20 plus 3 times 30 plus 4. Watch this. 20 plus 3, this is a binomial. This is also a binomial. 20 plus 3, and then my other binomial, 30 plus 4. Notice how I'm writing the sign in front of it. If I were to find the area for each of these, I'd be taking the length times the width, or length times width, whichever one you want to call it. This case, 20 times 30 gives me 600. Over here, 20 times 4 gives me 80. Just finding the area for each of these boxes. 3 times 30 gives me 90. And then once again, 3 times 4 gives me 12. It's all positive. They're all positive. So once I get the area of all these little squares, all 4 of them, to find the bigger one, all I'd have to do is add up all the areas of the little ones. So 600 plus 80 plus 90 plus 12. This gives me the sum of 782. Oh, look at that. Isn't that the same as what we got here? Indeed it is. So recall your exponential rules. What's the difference between x squared times x cubed? Well, versus x to the 2nd power raised to the 3rd power. This gives us x to the 5th versus x to the 6th. Remember, we are multiplying here, we are adding here. Over here, again, we are multiplying, so add your exponents. Keep the base and add your exponents. So this is x to the 5th. Okay, next. We're going to simplify this monomial. This is a monomial times this binomial. Actually, this whole thing is a monomial. So just bear with me. We're multiplying a monomial times a binomial, which is in its entirety a monomial. Okay, so here we go. I'm going to write x cubed here, my monomial. My binomial gets split apart up here. 3x squared plus 7x. So notice how when you have a binomial, you're going to have 2 columns or 2 rows. When you have a monomial, you're going to have 1 row or just 1 column. So here we go. This becomes 3 times x to the 5th. And this area here becomes 7 times x to the 4th. So when I want to talk about the entire totality of this rectangle, the area of this rectangle, I would simply add the areas. 3x to the 5th plus 7x to the 4th. Okay. If we were to apply that property here, we would call it the distributive property. Okay. So we would take this and distribute. Take this and distribute. So x cubed times 3x squared gives me a 3x to the 5th. And then x cubed times a positive 7x gives me a positive 7x to the 4th. Oh, look at that, my darlings. Our answers match. So either method, it should work. This we use the distributive property to multiply. Flip the page to number 5. How can we multiply two binomials? I'm going to show you two ways. Double distribution or FOIL method. I'm just going to dive right into the FOIL method. You're going to take the first terms, x times x, multiply them. You get x squared. Then you're going to take your outside terms. I'm going to do a different color. Your outside terms, that is your x times 5. And x times 5 gives you 5x. Then you have 3 times x, your inside numbers, which is 3x. And then you have your lost terms. L means lost. This means inside. O means outside. And F means first. Okay, so your outside terms are going to be your x times 5. Your inside terms is your 3 times x. And then your lost terms is 3 times positive 5. Yep, take the sign with it. That's positive 15. But we're not done yet. You need to notice that we have like terms. X squared plus 8x plus 15. Always combine like terms when you can, and you end up with your trinomial. A binomial times a binomial gives you the trinomial. All right, let me show you the box area method. Box area method. Binomial times a binomial. So I need 2 rows and 2 columns. I've got x plus 3 and x plus 5. Now find the area to each of these little boxes. X times x gives you x squared. 5 times x gives you 5x. 3 times x gives you 3x. And 3 times 5 gives you 15. Now what we're going to do is we're going to go ahead and add up everything inside the box. We've got an x squared plus 5x plus 3x plus 15. Go ahead and combine like terms, and you have x squared plus 8x plus 15. And it should be the same that you got using the FOIL method. Okay, so here's what I'm going to have you do. The bell has rung. I will continue this in another video. However, I need you to try this one, number 6. What does it mean when something is squared? You're going to take 5 squared and break it down to 5 times 5. That's what it means. 5 times 5 is 5 squared. So if that's what that means, then imagine what x minus 2 quantity squared means. X minus 2 times itself. Okay, so keep that in mind when doing this problem on number 6. All right, guys, I'll have to make another video. The bell has rung, and I got to let you guys in. Talk to you later.